so let's get to it here. Everyone, calculator, because you are going to have to crunch a couple numbers here. Do you remember from our area unit, not surface area, which is we're in now, but our area unit, we talked about if two figures are similar to each other. And I know the similarity ratio. So I know the ratio of all these sides is 4 to 5. Do you remember what other ratio I knew then? Their areas. What do I do to find the areas? So the areas would be in a ratio of not 4 to 5, but 16 to 25. And I'm still waiting. What other ratio would be in a ratio of 4 to 5? Perimeters, yes. Okay. We are, no pun intended, doing something similar to that, but now with 3D figures. Okay, 3D figures. So what's it mean first right off the bat if two solids are similar? Two things. One is if they're the same polyhedrons. You can't have a cylinder and a cone similar to each other. All right, so same polyhedrons. I want to say multiple edges, maybe. I could be making that up. Because I know poly means multiple. So.
Two or more edges.
Okay. And also, and you guys know this from all the time we've talked about similar figures, corresponding lengths are in the same ratio. How many times have we heard of this term, similarity ratio? What is it then? Describe to me what of two figures, the similarity ratio.
It's one of those words that's hard to
No.
Okay, so
it's the ratio of two corresponding lengths. In the area unit, we used S1 over S2 to denote the similarity ratio. All right, I have two prisms up here. Are they similar to each other? Two prisms. First thing we check, they're both prisms. Good. They're both prisms. Are the corresponding side lengths all in the same ratio? That's what we have to test right now. So here we go. Does 7 over, what would the 7 match up for its similar? The 7 over 4, is that the same as 14 over 8? And guys, 2 out of 3, just because it works, it's got to work for all 3. So same as 10.5 over 6. How would I figure out if all those ratios are the same? Yeah, okay, that's why we have our calcs out, right? Let's find out if they all have the same decimal equivalent. And what do you notice? They all come out to be 1.75, 1.75, 1.75, right? And again, I can't stress that enough. It's got to be all 3 have to be in the same ratio, not 2 out of 3. So yes, they're similar. What would be your similarity ratio now? You guys could have multiple, infinite answers here. 1.75 to 1. Others? 7 to 4. 14 to 8. 10.5 to 6. Multiple ratios you could have. They're all the same. So you could have 7 over 4. You could have, I'll take Sean's first one, which is 1.75 over 1. Okay, multiple similarity ratios there. How about these cylinders? Well, they're both cylinders. There's number 1 checked off. How about corresponding side lengths? 9 over 5, same as 12 over 9. What are you finding? 9 over 5 equal 12 over 9? No go. So these are not similar. All right, so all good that they're testing if they're similar or not. Just match up all the corresponding lengths and see if they're all in the same ratio. Questions, comments, concerns? All right. Well, first thing I need you to do here, there's a little, do you guys have this on yours? Or did I get rid of it last year? You guys don't? God, nice. Good man, Carlino. Learned my lesson from last year. Okay, here we go. If you know the similarity ratio, the ratio of two sides, you also know the ratio of their surface areas. You also know the ratio of their surface areas. They're not equal. The ratio of the sides, S1 over S2, is not equal to the surface area ratio. How do you think you fix it? Surface area. So whatever the ratio of two corresponding lengths is, it will be squared the surface area ratio. And what if I wanted to go backwards? What if I give you guys this today and say, hey, what's the ratio of two sides? All right, you guys are good. What about volume? Do you think that's equal to the ratio of two sides? Nope. And I don't square them either. I'm going to. Oh, so it's got a relationship with your units that we always put on. I'm going to cube them. Oh, and here, oh, big vocab. What if I give you the volume and ask for the ratio of the sides? Oh, we'll be going to that bad boy today. Yep. Oh, how about those days, huh? We were doing that in Algebra 1 today. Yeah, those were fun. Remember those where they intersect? Parabola, line. Yep, fun times. Not fun for me. All right, good times. Here we go. Okay, I'm going to tell you each pair is similar. Can you guys find the similarity ratio for me? So one side to another side. If I know the surface area of one is 49 and the surface area of the other is 81. So I know the ratio of the surface areas is 49 to 81. But you guys are trying to get me to the ratio of the lengths. So if I know the surface area and I'm trying to find the lengths, I can't go one, got to go last day here. How can I use that info? Here we go. 2. Square root them. Yes, I'm going to square root them. So the similarity ratio will be 7 over 9. Ooh, volume now. But I need to know the volume. 125 to 512 is the volume ratio. But I'm looking for, again, what's the ratio of the sides? The similarity ratio. Suggestions, what I can do with the 125. 8 suggestions. Cube root. Do we remember that day doing spheres?
Yes.
When we took the cube root? Math. Under math, choice 4, yep. And the similarity ratio? 5 to 8, yes. Okay, everyone focus in here on these next two because this is where it gets a little hardcore today on these next two. Is actually using these to set up my own ratio, proportion to solve. All right, here you go. I'm going to give you the surface area of two figures and the volume of the larger one. What's the volume of the smaller one now? Okay. First question. What am I asking you to find? Volume, which means I need to know the ratio of the volumes. All right, if you're asking me to find volume, great, I got no issues, but you got to tell me what the ratio of the volumes are in. And you guys know, whoa, the only way I can find volume is what? By cubing the similarity ratio, right? I don't even have that. But how can I get there? Okay, I know the surface area ratio is 75 to 108. I asked you for the volume, so I need the ratio of the volumes first. So how do I get from here? Here's my path. I got to get from here to the volume ratio somehow. What do I do in between here? How do I get to that volume ratio? Okay, so I'm going to go side ratio first. And how do I get to that side ratio? All right, here we go. Leave it as a fraction. Square root of 75 over square root of 108. Everyone can get 5, 6. Change it back into a fraction. Okay, that's 5, 6. What would be the ratio of their volumes now? What do I do with 5 and 6? Cube them. Yeah, cube them. And the ratio of the volumes? That's the ratio I need in my proportion right now. So I know the volumes are in a ratio of 125 over 216. What is this 216 here? Larger or smaller one? Larger. So and this one, I should have did second, but it's fine. And solving for the volume of the smaller one now. If you ask for volume, you need the volume ratio. If I ask for surface area, you need the surface area ratio. And x, I know you don't have to cross multiply here. It comes out to be 125 cubic centimeters for the smaller volume. Okay, I'm going hands off here. Let's see what you can do for the next one. I give you the surface areas, but I want the volume of the smaller one still. Volume of the smaller figure. So first thing, okay, this guy's asking me for the volume, so I need the volume ratio. That's your first job. From surface area, get to the volume ratio. You got it. Okay. I'll start. You knew the surface area was 16 to 25. Lead me your path to get to the volume ratio. 15? Okay, what'd you get there, Emily? Okay, what's that 4 over 5 right now? It's the ratio of the sides. Perfect. And then now I need the ratio of the volumes, though, so what'd you do to the side ratio? You what? Okay, so what is the ratio of the volumes? 65? Yep. Well, you're done. Thanks. Easy. Trying to show off. So there's the ratio of the volume. So now I can set up my proportion with it. Where's that 500 going? 11? Because it represents the larger one, so 500. What is the volume of the smaller one? And what'd you get there, Emily? 256. Thank you. Good job on the units. Okay, should we have a moment of silence here? Last one. Okay. Okay, let's get going. We got a block of ice, 2-pounder. Probably. Actually, now that we're on the last problem, let me do this. I did not put it on your quiz, surface area quiz, but I did put it on my other geometry kids quiz. So I just want to right now, I know this is going to be a big moment for some of you, is reveal the identity of Big Al. Who is Big Al?
Let's see it. I'm nervous. I'm not mentally prepared for this.
You don't know when it's gonna come.
Big Al. Shown below.
Is shown below using a cylindrical lawn roller.
He's old school. I like it.
Everybody, Big Al. You've ever seen, not mow a lawn, but the seeding. You put seeds down to like the lawn grow. Down. Big Al, everybody.
I like the cat.
Yeah.
Like he's business down below.
There he is, Big Al.
Definitely wearing a striped sweater.
All right, let's finish this up strong. You got a block of ice that weighs 2 pounds. How much does a similarly shaped block of ice weigh if its dimensions is twice as large? A lot of people just say, boom, 4 pounds, I'm done. I just doubled everything. It's not how that one works there. Okay, not how that one works. First of all, weighing. Surface area or volume, you think? It's mass, right? Volume. All right, so this is going to be volume when I'm talking about the weight. So if I'm going to set up a proportion here, I need to know the volume ratio. Anybody know the side ratio of these two blocks of ice? Why 1 to 2, Sean? All the dimensions are doubled. Okay, so the ratio of their sides is going to be 1 to 2, yep. And is that 2 pounds for the smaller block of ice or the bigger one? It's for the smaller. Wait, you said the answer wasn't going to be 4. It's not 4. Side ratio and the volume ratio always equal? No. What do I still have to do to 1 to 2? How much does this block of ice weigh? Yeah, a little bit more than just doubling it, right? Here, hey, just and I'll end it on this because I know where there's still a little bit of confusion. Go ahead, give me a side length for this block of ice.
7.
Okay. They're all 7, right? What's the volume? How could you find the volume of that cube of ice? 7 times. Okay, go ahead for me real quick. 7 times 7 times 7. I double the dimensions now. It's what? 14 by 14 by 14. Go ahead, everybody.
2, 7, 4.
How many times does 343 go into that? 8 times, right? So what happened to our weight of our ice? We multiplied it by 8. Okay, that's where that's coming from. Just because you double a dimension doesn't mean the volume gets doubled. It gets what? A cube, right? 2 cubed, 8. So it actually multiplies itself by its size by 8 times itself. All right? It's a wrap. That's a wrap. We still have Regents review, yes, but new stuff, that's a wrap. And you guys have no idea what's coming with the Regents review, but all right, no joke when it comes to the Regents review. All right, so plenty of time here. Let's start the